Hello everyone, my name is Chakrara Janagam. Today in this video I'm gonna give a quick overview of Openshift with the help of a very generic demo that will cover uh, a good amount of features of Openshift. Let's get started. The agenda is simple. We're gonna give a quick introduction to OpenShift, like how to set up and what is OpenShift, and also go over some of the developer views and also operations aspects of OpenShift. Okay, that let's get started. OpenShift is basically a you can consider it as a platform or like the dad says, it's a container platform for your organization. Um, so in a nutshell, this is what OpenShift has in its architecture. So it has a basically a compute level where you can run your cluster on maybe bare metal servers, virtual servers, or private or public servers, and all the nodes are basically maybe Red Hat or Atomic based CentOS nodes, and you have masters running which basically typically take care of scheduling and managing your containers on the cluster, and also nodes host the actual containers, and all these application containers that are running inside the cluster talk to each other based on a service layer. So this is like internal load balancer for applications, and when you want to expose these applications outside, you basically use a routing layer which can be HA proxy or a Fi based load balancer. Okay, OpenShift also provides out of the box a persistent storage layer. So if your app needs some kind of persistent storage to run, you can basically use that. So you can run mode 1 and mode 2 applications both simultaneously on your OpenShift cluster. And also out of the box, it provides an internal Docker registry where you can push your images and deploy from there. I'm going to cover other features in the next slides, but this is what is OpenShift at a high level view. So how do I set up OpenShift? OpenShift comes with a very simple one line command to basically set up a internal OpenShift environment on your laptop. Um, for that, you basically need to have a OC command line tool binary on your local machine. You can get this binary from GitHub. If you go to github.com/openshift/origin and go into releases section, and in this you can basically download the binaries from based on your environment. You can choose Linux or Mac or any other binary that you need. So you download this binary and put it inside your path. In my case, I put it in user local bin OC. So that's where I put it so that it is automatically detected. Okay, so this is what you have. Once you have that, you can get started with setting up OpenShift local environment and start deploying applications on top of it. Okay, so I'm inside my demo repo. I have a demo script for this. Okay, let's go back to my presentation and let's get started. So all you need is OC cluster up for this. But if you want to have metrics, you need to add one more flag. That's all you need. Give me 1 second. Let me clear this up, right? And then set up. So OC cluster up -- metrics equal to true. That's how you basically have metrics also installed onto the cluster. If you don't want metrics, you can just skip that part. So it's going to set up a local OpenShift cluster. I have already one cluster running on a machine, so I need to take that down. OC cluster down. That will bring it down. Let me bring it down and show you the complete thing. So it's taking it down now. Okay, so let me start this. So it's going to create a lot of things for you out of the box, so you don't need to do all these customizations. The only prerequisites for this is to have Docker daemon running on your machine, and it is accessible. And you download your binary and then do OC cluster app uh, from the from from the binary path. So it's also going to create a default project called my project, and you can see this is a URL that you can hit and log into the OpenShift cluster. Okay, and by default out of the box it creates a few user accounts, but when you install this way, OpenShift allows all users to log in. So essentially you can log in with any user, but you can always change this authentication mechanism to use a different method also. So this is just for development purpose. Okay, so I have this OpenShift cluster running here. I'm going to log in into the cluster. Let's say I log in with Joey. Type password also Joey. It doesn't really care because I did not set up any authentication there. Once I have this user, or I can just use a developer user also. So both are same. I have this Joey user logged in now, and let's say if I want to make this user a super admin for this cluster, the simple command for that, OC first login as system admin on the master or wherever you have your OpenShift installed, the certificates installed, and then after that you execute this simple command called OC ADM policy, add cluster role to user, add a cluster admin privileges to the user called Joey. That's all you need. Okay, so that Joey will have a cluster wide permissions. Once that is done, you can see that Joey has now access to many more namespaces, not just my project. Okay, what is the significance of these namespaces or projects? This default namespace basically hosts two applications here. One is Docker internal registry, this one, Docker internal registry, and also a routing layer too. So this is a routing layer. So this also runs as containers inside OpenShift, and also OpenShift Intra will host the metrics part of it and many other different namespaces for different purposes. Okay, with that, let's get started into the actual demo. So once my cluster is up using this simple command, it's as easy as running one command to have your local OpenShift environment. So once we have the environment, what is the next thing that you want? You want to deploy Docker applications onto this OpenShift cluster, right? So there are multiple ways of deploying applications inside OpenShift. I'm going to discuss each of these and show you different ways so that you can choose whatever way which is convenient for you. So by default, OpenShift allows these many methods. You can use a Docker image which is already built somewhere, which is available somewhere in the cloud, and you can basically pull that Docker image and deploy. OpenShift, whatever that is created by OpenShift or that runs is basically pure Docker images, so you don't need to worry about whether OpenShift is injecting something or not, something on that. It only injects some metadata, but it's not really a drawback for you if you want to use some images that are built inside OpenShift to other environments. So in this case, I'm going to show you different ways of deploying it. So let's say I have a Docker image already somewhere in some registry. I can pull that Docker image and deploy using this first method. And the second method is using a Docker file. Let's say you know how to write a Docker file, and OpenShift will basically read the Docker file and build an image for you. Okay, so that's another way of doing it. What is the purpose? So you can use cluster resources to build the OpenShift images instead of on your local machine. And also there are many more advantages, but it's not really the scope of this video, but that's why I'm skipping it. So the essential part is you can also create a Docker file in your source repo, and OpenShift will read the Docker file and build an image for you. The other way of building image is called source to image. Let's say your organization is big and some people know how to write Docker files, but some people might not know, maybe learning now. Source to image enables those beginners to get started with Docker. So they really don't need to know how to write a Docker file to basically deploy applications as a Docker image or Docker containers. Okay, so what is it? How does it do? So source image, what it does is it takes a base image and it takes your source code and combines both of them together, installs all the dependencies, so it adds one more layer on top of it, and then creates a Docker image out of it. So this is done all out of the box. So you don't need to know how to write Docker file, how to do a Docker build and all. So this is taken care by OpenShift. How it does, we can learn more in next few minutes. But understand that you just supply a base Docker image, what image you want to use, the name of the image, and give your source code, and OpenShift will basically take care of uh, creating a Docker image from that. And the next thing is binary deployments. Let's say you have your jar files or var files generated out of OpenShift, and you just want to deploy these binaries to be embedded into, let's say, if it is a var file, you want to embed into a Tomcat application and create a Docker image out of it. So you can do that as well. Okay, so multiple ways of doing it. You are not restricted to any type of deployment. You can choose whatever is convenient for you. Templates is another good feature in OpenShift that I'm going to cover. Templates are like your click to deploy things. So by default, OpenShift provides a lot of templates, but you can build your own templates and publish it inside your internal organization so that everyone else can basically click and deploy your application. Okay. With that, let's get started into the demo. First, let's see how we deploy a Docker image. Okay. So I have a Docker image out in the Docker Hub. So I want to deploy that image. Okay. For that, if I click on Add to Project, click on Deploy Image, and then click on Image Name. So I have my Docker image somewhere in hosted by Docker Hub. So that's called docker.io/mysql. So this is hosted on Docker Hub. From the Docker Hub, I'm going to pull that image and then deploy it in OpenShift. So okay, click on Enter, and then it shows some warnings. The default Docker image that is available in Docker Hub is running as root, which is not preferable, and you don't want to run your containers with root privileges. It just shows an warning, but it might be able to still run it. One thing you need to take care of is if you are deploying something from Docker Hub and it is not working in OpenShift, that doesn't mean OpenShift is not working. So that probably means that your by default OpenShift doesn't allow root privileged containers to run, and you need to enable some very quick policies to run them. But we would not suggest to run containers as root. Okay. All right, so I have my Docker image referred here, and I also have the metadata, and I need some environment variables for this image to run. That's MySQL root password. Let's say this is password. Okay, I can add more environment variables and choose also labels. Labels are very important if you want to target your. They're used for many other purposes. One purpose can be like you want to target your application to a IO intensive, IO good, like some node which has good IO, you want to point your application to that node, you can use labels for that purpose. But the idea is labels are just like key value pairs, but these features are very powerful when it comes to deployment strategies. Okay, that's it. And then let's get started by deploying by hitting this create button, and you can see image is now getting pulled. I'm skipping these health checks and all temporarily. Image is now deployed. The MySQL container is now deployed. Okay, so if I go click here, click on this, I can see the environment variables, I can see the logs. So MySQL is now booting up, and you can see that it is running, it's still booting up. Okay, can click on follow here, and now it is running on 3306 port. Okay, so your MySQL is ready for consumption. And let's say you want to do some debugging or maybe look into the container, you can just go click on terminal here, and you have your MySQL instance here. Okay, so MySQL, you are inside the MySQL container. Obviously it is not connecting because I did not provide any username and things and all, but you get an idea. Okay, all right. So I have my MySQL container running. How do I start using this? Okay, uh, so for any applications that is running inside the cluster, MySQL is available using a simple service name. So OpenShift already has a internal DNS name called SkyDNS. So if you deploy some applications inside OpenShift, it automatically will be able to connect using the service name. So in this case, I'm using the service name as MySQL, but I can choose like MySQL/dev or /UAT something, and then any other application that wants to connect to this MySQL instance, they can just use MySQL as a service name, and then connect to that using the credentials that are provided. Okay, so as simple as that. But if you want to expose this outside, that's a different story I'm going to cover. But understand that all things that run inside cluster or in namespace are reachable via a internal service name. Okay. Let's say I have this MySQL running on the OpenShift cluster, but I want to connect it from my local machine. Why is it useful? Because sometimes I want to connect this MySQL instance using an IDE, right? So I have a MySQL IDE where I edit these SQL queries and all. I want that IDE to connect to the MySQL instance. So how do I do that? I can port forward the container traffic to my local port so that it simulates that as though the MySQL is running on your local machine. Okay, so let's go and do that. All right, so OC project, let me see if I'm in the correct project. I'm inside my project, that's this one, and then do OC get parts. That shows me my MySQL part. Okay, and then OC port forward, and then what you do is give the container ID and local port number where you want to forward this. So 3306 local port, and container port is again 3306. So what it does is basically the address is already in use on my local machine, but I can change it to a different port, 3308. Okay, so it's now forwarding the container 3306 port traffic to 3308 port of my local machine. So for my IDE, the MySQL editor, I can just point it to 3308 port on my local machine so that I can be able to seamlessly connect to the MySQL instance. Okay, that's the simplest way of doing the connection. But also I can do a connection like SSH connection to the container as well. So the SSH alternative is OCRSH. That means do a SSH into the container, and this I give that OCRSS and then container ID. So that will go into inside the container. So I'm inside the container now. How do I verify? If I do MySQL, it's showing up connection error. So basically I'm inside the container. Okay, I think you get it. I'm gonna exit from that. So many ways of connecting it to the container. Okay, it is also useful if you want to have some debugging. If you want to do some remote debugging, you can just do a port forward to your developer IDE. If it is not MySQL, maybe your Node.js application or your some other application, and you want to do some node debugging, you basically port forward your traffic to your local machine and then start debugging there. Okay, it's as simple as that. So we have seen how to deploy a application from using Docker image. Let's walk through some of these and also show some of them as a demo. So um, before I hit this Docker file, let me go through the source to image part so that I can relate this to Docker file. Okay, let's go to the source to image process first. So what is source to image? Like I said, source to image is a process where you have developer doesn't need to know how to write a Docker file or how to create a Docker image, but he or she will be able to use Docker runtime for deploying applications as Docker containers. Okay, so let's say I'm a developer. I don't know how to write a Docker file. I want to deploy a Node.js application. Let me go to my Node.js application. This is a simple Node.js application, nothing specific to Openshift. This is pretty generic Node.js application. So I have a server.js, I have a package.json where I have my dependencies mentioned. So if I go here, I have my dependencies mentioned. I also have, if it is a Java application, it can be pom.xml file like that. So if you know build packs like in Heroku or Cloud Foundry, it's basically a build packs type of method, right? OpenShift will basically understand based on the type of this file. It will understand what to install during the source to image process. Okay, so it takes your base image. For these, it takes a Node.js base image which has already Node.js installed, and then it puts the source code of this repo, and it reads the package.json. It installs all the dependencies and creates a Docker image out of it. So this is done all automatic. You don't need to, the developer doesn't need to know how to write that, how to create that. So as a developer, I have this simple application that I want to run it inside a Docker container, okay, using Docker technologies. So I'm going to copy this repo here, and then after that, I'm going to add to project. So this is called templates or the image streams. So what does it have? OpenShift basically supports a wide variety of languages ranging from Java, PHP, Ruby, Perl, Python, Node.js, some databases, all of this stuff. In this case, I'm going to choose Node.js. So this is your Node.js is your base image, okay? And then I'm going to mention this as welcome. Application name is welcome, and I'm pointing the GitHub repo to the repo I have here. Okay, let's go through the contents of this server.js so we'll understand what we are deploying. So this is a pretty simple application. When I hit the root URL, it's going to give hello world, the version number, and also the host name on which this application is running. So the container name essentially, and also it has few other features like health checks. And also health check is basically when I hit this URL, it is going to respond 200 or 404 based on this parameter value. Okay, I can change the parameter value using when I hit this /cancer endpoint. I'm going to change this healthy parameter to false so that I can make this container unhealthy. So I'm going to use these features to show some of the operational features, but understand that this application has some endpoints to basically check health of the running container. Okay, and also I'm also capturing the exit of the application, doing some cleanup process here. So this is very essential. Okay, this is not mandatory, but this is what I recommend. So once I have this app, I'm gonna create an application out of it, create a Docker image out of it, and then by just pointing, all I need to do is name the application and then point it to the right repository, choosing the base image. That's it, right? I've done nothing apart from that. I've not written any Docker file, or I've not written any Docker based things at all. But still, we are able to deploy in few minutes. Hit create, and then click on continue, and you can see one build is happening here. Go click on view log. So it's cloning the repo using the Node.js base image, and it is now reading the package.json and then installing all the dependencies and then create a Docker image. Okay, so let's wait for a few seconds for that dependency installation to complete, and you'll be able to see a Docker image that is built out of it. Yeah, it's now installing the dependencies, and after the dependencies are installed, it has created a Docker image, and it is now pushing it to the internal registry that we have seen in the beginning, right? So we have an internal Docker registry. So the build is complete. It has created Docker image, and it is now pushing it to the internal registry. So 81% is complete, and you can see this is the name of the image. Okay, and this Docker image is pretty similar to what you create. Well, you can literally take this Docker image and run it on a Docker engine that is available on your local host. So no impurities added. Okay, and click on overview. I have the application deployed into the internal registry and also pushed into the internal registry and deployed in the cluster. Okay, right. So application is up. Let us go and hit this URL to see if the application is really deployed or not. Before that, let me go and check if the boot up is complete. So the boot up is complete. I hit this URL, it's going to show hello world version and the host where it is running. As simple as that. Okay. All right. So I have my application deployed, and Docker image is created. If you want to see the Docker image, go click on builds and images. This is the image that you have. Okay. Welcome image. And you can create more copies of that application just by referring that image. Once the application is ready, using the source to image, you can keep changing the source code and getting redeploy the images, redeploy the newer Docker images. Okay. For that, what you need to basically do is go into builds, click on selection, and then click on configuration here. This is a webhook, generic webhook URL. So copy this webhook URL and update it in the GitHub. Whenever you change the source code, it automatically goes and deploys a newer version of this application. So you are partially doing your CI/CD process. So okay, that's a very good feature. And also, if your GitHub is not able to communicate with this local instance, you can go click on builds and then manually trigger that build. You can do that as well. Let me show you some of those aspects. Right, so what I'm going to do is change the source code here and then trigger a new build so that it will deploy a newer version. Okay. Before I do that, let me quickly scale this up to some other container number, because let's say this application is receiving a lot of traffic. I want to scale this application, let's say, to 4. So it's now slowly scaling to 4. So within few seconds, you are able to scale your application to 4 instances. Okay. So I go click on this. It is still showing me. If I refresh every time, it still shows the same host name. This is because by default, Openshift enables sticky sessions on the session. so that it will, every time you hit this from the same browser, it goes to the same container unless the container dies. Okay. Um, and let's verify if this really doing a round robin or not, because from the browser I'm not able to verify that. That's why I'm going to use CLI for that. Okay. Um, let's do this. While true, do a curl request on this application and sleep for 1 second and then done. So you can see every time it hits the application, it is giving a new host name. So that means it is really doing a round robin. Okay, so that's what you have. So out of the box, you can do load balancing without worrying about all the pieces that you need to, all the tooling that you need to build around to make your application a load balanced application or scaling your application. Okay, this is manual scaling when you hit this button, but you can also have auto scaling enabled, that I will cover in some other future videos. But think of it as like you can do manual scaling and also auto scaling. Okay, so I have version 1 application running here. I have 4 instances, so it is doing a round robin between those 4 instances. So once I have this, I'm gonna deploy a newer version by just changing the source code here. Let me take out this, and I'm gonna deploy a newer version. Okay. So if I have the GitHub hook set up already, it will automatically trigger a build here. Since I don't have the automatic trigger setup, I'm going to kick off that manually. So OC start build, and the build name is welcome. Okay, so this triggered a new build. You can see it here, and your application traffic is going to version 1. It is still going to the version 1 because the newer version is just building. The image build is complete. It is now deploying it, and you can see your traffic is still going to version 1, and it is switching to v2 sometimes because it is doing basically a rolling deployment. You can see it is basically switching between version 2 and version 1 without any break in the traffic at all, right? So it is out of the box. It is doing a rolling deployment without any interruptions on the traffic. Okay, so your incoming traffic is same even if you are deployed the newer version. So you can see all of the applications are on version 2 now, right? Okay, you can ignore these pieces. You don't really need to care those errors. As of now, I'm going to explain more in future videos, but when you don't handle the exit, it basically throws that error. So we have your version 2 application running, and you are able to do successfully a rolling deployment, or let me call it as A/B deployment. Okay. Some of the features that you can place on top of it, this is basically A/B health checks. Okay, so I'm going to jump into some of the operations aspect before I cover these. So please hold on these. I'll come back to these once I show all of these features. Okay, so I have my application running, and what I want to do is now basically set up health checks for this application. So Openshift will basically take care of the health of the application rather than you waking up in the middle of night and then restarting it or redeploying it and all. Okay, so out of the box, when you deploy an application, even if you don't specify any health checks on it, Openshift will look for the process health and then act based on that. So how does it do? Let's say I have 4 containers running for this welcome application, and let me kill one of these. OC delete pod, and then kill one of these. Immediately Openshift detects that, and it automatically heals that application and brings it back to the same stage where we desire to. Okay, so it's trying to scale to 4 because one of them is died. It's basically kill that and also bringing back to the stage where we wanted that to be, to number of containers as 4, right? So give it few seconds and you can see that it's scaled to 4. And meanwhile, on your traffic, you are still seeing no interruptions at all, right? So it's taking care of your health of the application. It's taking care of your deployments without you going and fixing it in the middle of night. Um, and some other health checks that you can mention is uh, a liveness probe and also readiness probe. What are the differences between these two? And also how can we configure these? Let me go through applications and choose the application and click on actions and edit health checks. So you can set up two types of health checks. One is readiness probe, another one is liveness probe.